All right, give me a second here. Magic happens. All right. Anybody need another round of beer? Feel free to, I think there's, are they still serving out there?
Yeah, I think
Yeah.
so.
Okay.
And there's still more food too, so please, partake.
We can't take the pizza home. Yeah, I'm from Solid Fire, and welcome. I guess you've already been welcome. So let's just kind of jump into this. I guess give me one of those.
Okay.
So we're going to talk a little bit about more depth about Cinder here. So we have a couple polling questions that we kind of go through at the beginning of this here. How many of you guys are already using OpenStack? Okay, how many are contributors? I know him. How many of you are operators? Okay, a little bit of everything here. All right, I don't know. That's enough. How many of you are here for just the food and the beer? Okay, all right, that's fine. So some of you guys are probably wondering who I am. Sometimes a colleague of mine comes out and does these. He used to be the PTL for Cinder, and the current PTL is actually here, so he's taking a picture of me right now. The gentleman, Mike Perez over here with the green hair. I'm recently joined SolidFire. Before that, I was actually with Fusion.io/SanDisk, and I contributed some drivers from Fusion.io into Cinder, and now I work with John and help him with some of these events. So I got elected to come to California. So, how many of you are familiar with SolidFire? Everybody's kind of heard of us, okay? So we're based in Boulder, Colorado. That's where I'm located personally myself. So we are a storage company kind of focused on cloud and OpenStack and scalable storage. So just to give you the brief bit about that. So what we like to do talking about Cinder and talking about OpenStack is when you think about OpenStack, there's a bunch of pieces of storage here. And how many of you guys are familiar with all of this and can rattle this off the top of your brain quickly? I don't see a ton of hands. All right. So how many of you are familiar with the term ephemeral? Right? Ephemeral storage is really the storage that kind of comes with the instance. In OpenStack, instances are potentially short-lived, right? So you got a piece of storage, you write your log files to it, when you kill that instance, it goes away. And that's the term ephemeral, if you're not familiar with that. It sounds like most of you are. We also talked a little bit about object storage, and Trevor assumed that everybody was familiar with object storage. Everybody familiar with object storage? Okay, nodding your head, so you get that. Commonly Swift. It's really, the thing about object storage is you want to read the whole object kind of all in big chunks. So it's not good for your database applications, right, that want to read 4K here and 4K there. There's also some shared file system options for storage around NFS. Your mileage may vary on how that works, but it's an option. But really, Cinder is about block, right? And that's how do we present attachable devices. It's like sticking a USB stick into your instance. Sometimes you might boot that instance from that USB stick. Sometimes you add it on as an extra piece of storage. Some interesting flies around here. Wow. So Cinder manages that, right? Cinder is all about how do I provision that storage off of whatever backend you have configured. How do you then present that to the images? When you take that back, what happens to it? Does it get destroyed? Do you make snapshots? Do you make clones? That's really, and think raw disk and database. Those are kind of the things that we're going through there, right? So I guess I've got another slide in here with a little more detail. Object storage is really ISOs, VM templates, those kinds of things. Obviously, VMware is doing some of that in their VMDK. The image storage is in there, but in normal OpenStack, you can put things like VM templates or ISO images into Swift. Over here, you would put your database and your apps that want really random access. So, if we talk specifically about Cinder, we like to put this up. It's the mission statement. I'll spend a little. You guys can read through that, but. I talked a bit about it. Cinder is really how do I manage storage? How do I make it so the cloud operator and then therefore your tenants can manage that storage provision, allocate, take snapshots, clone, those kinds of things. And how do I scale that out, right? So how do I have multi-tenants? How do I make that all happen and manage it all? When we boil it down, it's really simply about allowing you to allocate, attach, and detach. But then there's another key piece, and that is, how do I make this work with multiple vendors in the background? And that's one of the things that the Cinder project, which that's part of the reason it got pulled out of Nova, is to make it so that we could have more drivers, and the project could run faster for those drivers. So actually, I'm going to talk a little bit more here on this one. So that's been a big success of Cinder, is that we now have a generic framework for about 30 drivers. Just sliding here with all the driver lists from Juno, I think. I haven't really updated this for Kilo yet, because did it release yet, Mike? It's RC3? Okay. Yeah, nice. Nice. Okay, so he says he blames Nova, but we're on RC3 for Kilo. So it's coming out here soon. It's due out. It's literally like kind of every day. I was asking John, the former PTL, yesterday, did it drop yet? Did it drop yet? And it sounds like we dropped another RC release candidate. So yeah. Okay, cool. So we talked about allocate, attach. This is the kind of the simple screen up here. I do have a demo at the end. I'm going to try to do it live. Murphy lives in demos, so who knows, but I do have screenshots of kind of the interesting things. So this is the create volume bit of Horizon. You can see, you give it a name. Generally an empty volume. Volume type, we'll talk about that a little bit more here, and that's a way to pass interesting things into Cinder and tell it how you want to allocate that volume. And then a size and an availability zone, and away you go. And then the second big thing you're going to do is you're going to attach that instance. And so this is the attachment screen. You've selected your volume, you click attach, and it gives you a list of all your instances that are running and what you want to attach it to. In this case, it's going to auto attach. It'll just VDA is the boot disk, and then this would be VDB or whatever down the list of disks. So any questions on that? Everybody seen this before? Okay. So this is, I kind of jumped ahead a little bit in my discussions here, but really it's a plug-in architecture, right? So that's the key thing in Cinder, is that, you know, VMware has a driver that allows us to provision volumes off of their data stores. That's what they've built. It's available out there. If you built an OpenStack instance and it wasn't VIO, you could plumb that into VMware and still provision off of their VMDKs. Same with putting instances out on their ESX clusters through vCenter. It's a different driver. That's, of course, through Nova. So backend devices are invisible to Cinder. So all of us storage vendors, we all use the same API when it comes to Cinder, right? So I know there's a few vendors here. I've talked to a few of you. We all have drivers. But from a usability perspective, the users and the administrator and the tenant uses the same set of APIs to access everything. Then we have like filter drivers that allow us to kind of direct things, right? So we'll talk, at the bottom of here, we talk about extra specs and volume types. For instance, SolidFire is all about quality of service capabilities in the different volumes within our clusters. So we use extra specs and volume types to define how you're going to provision that volume. So you saw in that provisioning screen, there's a volume type pull down. When we define that, and I'll show you how you set that up, that would be how you would say, I want a gold, silver, bronze. Or if you're going through the VMware driver, that would be how you would pick the data stores that you're going to use, right? So those volume types are used to pass information that the backend can use. If you pass some of that information to a driver that doesn't need that stuff, it will just ignore it. So as part of Cinder, we also include a reference implementation. So this is where a lot of people get confused. The Cinder project also builds a LVM-based what I call a virtual storage appliance. It's really, you take LVM and the other tools available in base Linux and you build a storage box. And this is what you would use on your laptop, right? You create Cinder. As part of that, the Cinder volume process goes off and actually implements the storage, uses the iSCSI target and presents those iSCSI, those LUNs that it's created through LVM up through iSCSI. This is the way you build your kind of simple POC reference architecture, things you're testing. It's the reference architecture. Everything has to work in here, right? Because we can now run this as a VM in another cloud to run DevStack on OpenStack to test this stuff, right? So you can scale it. You can add nodes. You can some people use this or something similar to this in production. There are some large cloud vendors out there that use stuff very similar to this. It takes some understanding of how Linux is put together. This is where you actually would scale Cinder. So Cinder's really kind of three or four parts, right? It's the API, it's the scheduler, and it's the volume service. There's a backup service. The volume service, when it's running this reference implementation, you might have to have a number of these to scale your storage. When Cinder volume is running, talking to a back end, it's really a proxy for OpenStack APIs to vendor APIs for our arrays, right? So in that case, you can control quite a few arrays from that Cinder volume process because it's not a heavyweight thing. It's really translating whatever, the JSON and the requests that come in from OpenStack into whatever the array consumes on the back end. So it's not really doing the heavy lifting. Typical implementations is, somebody put in the slide deck a 5 terabyte reference for this, 5 terabyte maximum for this reference architecture. Your mileage may vary. Again, we've got some large cloud vendors that are using this. And also, there's no redundancy in this right now. So you can build that in yourself if you wanted to build DRBD and kind of build that, but it's not as part of the reference architecture. It's coming. They're working on it, so we'll talk about that a little bit in the futures. So here's the architecture of that. You can see over here we've got the controllers, the compute nodes. Again, those could be VMs as VMware puts those. And then you've got the Cinder node, and it's got volumes on it, and it's actually implementing the storage itself, right? So that's the reference architecture. But then we have the drivers. And I'm going fast. Any questions? I'm watching. Stick your hand up. Tomatoes? No? Okay. So then we have the plug-in drivers that allow Cinder to work with the various back-end pieces. And so here's a list of them. I think this is as of the Juno release. You can see all the different ones in here. VMware's VMDK driver is in there. Some of the other things. Yes? Oh, sorry. Okay, we'll get that fixed. Yeah. Spelling's not my forte, right? So there's a number of drivers. In some of the interesting things that I'm going to take a moment here to talk about this, and Mike, correct me if I'm wrong, but one of the things that the community's been working on in the last 2 releases has been to make these drivers much more stable and much better tested. So just to give you an idea, there is now a requirement that Mike is enforcing that all drivers need to have a continuous integration server so that they're testing every check-in that goes through OpenStack every time. So every patch, every little thing you change goes into the stream. Those continuous integration implementations at the vendors pull that stream and run the full set of tests against the driver and the hardware that's on the back end. So at SolidFire, we have a server that has a SolidFire array behind it that pulls all this stuff, runs the full suite of tests against our storage, and then reports that back. And I will admit, one of my drivers that I did in my previous life, Mike actually pulled, but rightly so, right? There was some company handover of change of ownership deal there, and the guys that wound up with that array did not implement a continuous integration, and so it has been pulled. So be confident that drivers that are in there are now being tested very well, and we are actually, for Kilo, yeah. We started to try to do this in Juno, but the enforcement was not heavy-handed. I don't want to say heavy-handed, but it's right-handed until Kilo, right? So that's the way to put it. All right, so when we do use a driver, what does it look like, right? What we've done is we've really moved the Cinder API over here back onto the controllers. So the light lifting stuff, we can even run the Cinder volume over there because it's then talking to the third-party storage, which is actually presenting those volumes out to the compute nodes. Any questions on this? Everybody familiar with this? That's the reference implementation. So that's the Cinder ships with the API and the scheduler and then the Cinder volume. And if the Cinder volume doesn't have a third-party array behind it, it implements storage itself using LVM. And in order to scale that reference implementation, you need to put more servers. If you're doing something like this, the array vendor may be able to scale that array, and you would only need one Cinder volume service to proxy APIs from OpenStack APIs to array-based APIs.
So in the other scenario, was it talking about scaling I/O or was it talking about scaling volume size?
Both, right? So in the reference implementation, I can take any computer, your laptop for instance, and configure it so that I can use those disks as the actual storage. So your mileage on that will vary based on how many disks you can stuff in a server and how many IOPS you can get off those disks, or if they're SSDs, and how much CPU you have to serve those out through the iSCSI target process and the LVM process that are running on that computer, right? So again, the reference implementation, again, there are large-scale cloud vendors that use that reference implementation as roughly speaking, as a way to deploy a lot of storage. There are also a lot of limitations to that reference implementation. And that's why we have these 30 some odd drivers for commercially available, highly available backends. So what we tend to see is kind of the first prototypes you're doing or things to test, you're going to run with the reference implementation. And then if you go into a production environment, you would want something from a supportable vendor to scale bigger. So you could still, in this point, if you did need to scale the Cinder volume process, you could actually run multiple of them and each one talks to a different back end. But again, because it's just doing API translation, you probably wouldn't need to scale those that way. Any other questions? So here's a little more detail. I like to throw this in here just so you know, we talked a little bit about all this stuff. You can see RabbitMQ and stuff. Over here, you've got Cinder Volume API, and you got the Volume Manager. And then, of course, since we work for SolidFire, you've got the SolidFire driver that's part of the Volume Manager, and it's really talking JSON RPC over to the Cinder, or to the SolidFire array. But also, I like to put this in here because you can see the iSCSI connection goes directly from the hypervisor over here to the SolidFire array. And so Cinder is not in the way of in this case, of the bulk data traffic. Now, when you're running that reference implementation becomes this array. Again, I call it a virtual storage appliance, but that's the reference implementation. And so that does have heavy lifting going on, and that's why that scales that way. So I think a lot of you customers out there, as you're deploying this as a production deployment, you would use you use a third-party array that can scale and has other capabilities in it. Yes. Correct. So yeah, this is, I'll repeat the question here. So SolidFire is a scale-out architecture, scale-out cluster, and so we have many different nodes. How does it figure out where to talk to? All of the iSCSI traffic comes into a storage virtual IP address, which is the initial target for the iSCSI client to talk to. Then it uses iSCSI redirection to point to where the node in our cluster that actually hosts the data. So. It actually, so the follow-on question is, does it remember where that is? Yes, once the connection's been redirected, the iSCSI connection will continue to that point. If something were to happen, one of our nodes were to die, the iSCSI initiator will then reconnect to that storage virtual IP address and maybe get redirected again. So it knows it's configured to always go to the storage virtual IP, and then the storage virtual IP redirects it wherever it needs to. So, no, the LUN actually lives, the actual data lives all throughout the cluster. The point at which we attach to that LUN lives in two places. One's the primary and one's the secondary, and so it redirects it to there, but then it has to go throughout the cluster to get the data. Sometimes the iSCSI's on an isolated network. When we set these up in the lab, we'll set that up as an isolated 10 gig network. Now, a lot of times we'll leave the routing on just so that we can get in there and like explore around. But if you were doing production, you might not even have a router on that network. So you can, there's ways to turn encryption on, but encryption for that bulk data traffic is pretty hefty. If you need to, there are options. Yeah. Yeah. Now the interesting thing is, this picture here has the iSCSI, right? But let's talk a little bit about the integrated OpenStack with VMware. They're actually provisioning this off of their VMDKs up to the instances directly. And so the actual traffic crossing the network to a storage array like that can be whatever protocols they support, right? So the array presents itself to VMware, and then VMware presents it up to OpenStack. So they actually support, Fiber Channel and FCOE and those kinds of things. So now you get that option. Now we're working through that in the OpenStack community to get Fiber Channel in there. It's out there. Is it all 100% mature? I haven't really looked at it, but I've heard that there are still a few things to be worked out. So, Fiber Channel, which is a totally different protocol at the lowest level, right? So it's a way to, now it's harder to hack it. I mean, there's switches and things like that still, so, yeah. Did you have a question? Okay, great. So what's it take to configure Cinder, right? That's, how many of you guys have done this? Again, VMware can do this automatic for you, but there's the config file, right? In this config file, I've got it set up here to show you 2 backends enabled. So we can support multiple arrays. If you had a SolidFire and an EMC or a tin tree, you can configure both of those into this, and the scheduler will then pick in some method of how to put the volumes on the different arrays. In this case, I've got the reference implementation is LVM up there. And you can see we've got a stanza for LVM. We got it enabled as a backend, LVM and SolidFire. We've got a stanza for LVM. We pick the driver and give it pull the backend name off the driver, and there you go. There's one of them. And then we've got the SolidFire array configured in there. Again, we get the backend name, we configure the driver, and we give it the login privileges to the SolidFire. Now that's to the management IP, so there's another IP for this management piece. Just, you were asking a lot of networking questions. So, and that gives you 2 backends. So now you use that backend name primitive, which becomes a volume type, if you want to select those. So you could actually have a pull down that said, I want LVM or I want SolidFire. Now as a cloud operator, you might put, I want silver and I want gold, right? And you charge per whatever volume type you're using. So these slides are a bit dated because Juno's been out for a while, but a couple things, kind of trying to bring the community up to speed on what's going on with the different bits. So Juno was the 5th release of Cinder, right? Because Cinder was a fork or a project that was peeled off of Nova. There was a lot of emphasis on testing and compatibility. They started the third-party CI at that point in time. Didn't really get to the enforcement pieces of it. One of the things that was added in Juno was an ability to manage and unmanage. So how do I pull in volumes that were already existed out there? I can now pull those into the Cinder management, or I can export them out so that Cinder's no longer managing those. So we started into replication consistency groups, continuing working on Cinder backup. Cinder backup is an ability to through OpenStack back up one of those volumes you've created. We're working toward incremental backups. Right now, it's a full dump into the object storage, but that's one of the things we're working towards. So, and a preview for Kilo. I don't think this has changed a lot, but this will be the 6th release. It's all about quality, really running the third-party CIs. I actually going to take you guys off here and show you something, just so you have an idea of what the third-party CI is like. This is a quick backport patch I submitted today. You can see up here, over on your left, That's the review cycle. Who's commenting on that? Thanks, Mike, for checking that one. But over here on the right, you can see all at the top, you got the Jenkins tests. Those are the normal tests that are run OpenStack on OpenStack. So DevStack is fired up somewhere in an OpenStack cluster or stack, and we run all the tests there. And then you can start to see down here all the other continuous integration servers run through and run their tests and report back. Now, some of them are non-voting, some of them are voting. And the interesting thing is then all these vendors also have to go through and give us some details on what happened. So when I drill into this one, I picked one of our esteemed colleagues here, and it has the console output from that test, so I can go through and figure out what happened. So this gives me an ability as somebody that submitted a simple patch to go make sure it didn't screw up a driver somewhere else. And I think the Nova project is doing this, and all these other ones that have third-party drivers are doing these continuous integration tests. So, any questions on that? How many of you guys have seen the OpenStack review site? A couple of you? Yeah. Okay. Cool. So, a lot of you seem like you've played with this some. Kind of got a couple of slides here. We usually wind up talking in some of the other parts of the country around, how do you make the choices for what you're going to do to deploy OpenStack, right? How do you figure out what you should, what technologies to pick, what storage to pick, those kinds of things, right? So there's a set of questions here, right? Does it scale? Does the architecture fit? You ask a bunch of questions about the reference implementation, right? Some of that is addressed in that, the first question, does it scale? Well, the reference implementation can scale, but it's got some hard points in there, right? So those are some of the things that you want to, if you're going to deploy. How many of you guys are thinking OpenStack? Kind of my polling questions. I see, yeah, there's a few of you, right? So you're probably asking some of these questions as I'm talking through this, and we want to bring these up just so that you're aware of them, right? How does the vendor that you're selecting work with the continuous integration? You'll notice a lot of those up there on that screen I brought up some of them are failing still. Are they actively involved? Are they actively participating? Are they looking at those failures? If you notice, I didn't go to scroll down to the log, but in the log there, a couple of the continuous integration vendors saw the failures and actually have resubmitted. There's a way to kick them again to resubmit it to try to figure out what's going on with their devices, right? So eventually, if they fail too much, Mike's going to kick them out again, right? And that's a good thing, right? So I know it's been rough, Mike, but it's a good thing that you're kicking them out, right? So are those vendors active in the OpenStack community? And that's why we're here to present to you guys, because we think it's important. So now the few words from the sponsor, right? So what is SolidFire? We are a scale-out storage system. Multi-tenant architecture. We're designed from the ground up for multi-tenancy. We do things like there's a different login for every tenant in OpenStack, right? So that's interesting, because if you have 100 tenants and you got to track down whose volume is where, now we have a unique login so we can see that these 10 volumes came from that tenant. We do non-disruptive upgrades and downgrades of the cluster. So a cluster is literally 5 appliances, 4 at a minimum. We can do that, but we like 5 better. You can add another node in there. We storage around in the cluster. If you take a node out, you need to have enough space, but you can take a node out. You can hot or cold, as long as you have this, right? You want to keep enough space so we can rebuild it. Automation is a top priority, right? So that's one of the things that we do. We go through everything's RESTful API so that we can easily make a Cinder driver. It's built to deploy OpenStack. That was kind of one of the first things we did, and it's not an afterthought. So if we want to talk more about that, we can talk more about it later. Here's another slide. We talked a little about QoS. Snapshots and clones, replication, all that stuff comes along with the architecture. But I really want to. Here's a couple more links. If you guys want to take pictures, we'll make these slides available. There's an OpenStack Solutions page out on our website. I don't have the actual link up here. I think I got it in another slide here, so you can take a picture of that. But we'll make them available so you can click on them. Since we're here being hosted by VMware, I want to take a few moments to put a couple slides up here. So a lot of the things that we do with OpenStack, we have some similar integrations with VMware. And I'm not going to talk about this slide, but it really shows that we have a dedication to VMware, we have a dedication to OpenStack, and that's where we're coming together with the VIO solution. There's another slide on it. I've got a couple of screenshots here that I want to take you through. Let's see, where do I have those? I'm going to jump a little bit. You guys want to see a demo, or do you not want to see a demo? You want to see all right, so we'll go through the demo. All right. Yeah, he wants to see the no-net. All right, so I'll take you through these couple slides just to give you, they're just a couple screenshots. You can see we have a plug-in to the vCenter GUI here, SolidFire. You click on that. Once you do that, you can start to provision data stores through that GUI. It has the built-in quality of service sliders at the bottom here, right? So if you're going to set up OpenStack on VMware VIO, you would set up your data stores this way. You might have a gold, silver, and a bronze data store. You can dial in their quality of service through this GUI to the SolidFire array, and then in OpenStack you can define gold, silver, and bronze. Obviously, probably would call the gold, silver, and bronze VMDKs, but you could mess with names and move around there. But that's how you would get this this capability. So now I will put the mic down. This way. So everybody wants to see me fail at a demo. I know. All right. So kick me out. I do have backup slides. All right. Okay, good. We've still got VPN access. So the typical OpenStack Horizon dashboard. What I'm going to do here is I'm going to go down through and show you how to configure volume types. Is that showing up? Okay. I'm going to show you how to configure volume types and set up the SolidFire array, and then we'll hopefully we'll get heat to work. We'll go create an instance with a volume attached to it, and we'll kind of watch how it all works, right? So in the volumes tab, this is administrator, so I logged in as admin to set this up through the admin interface. You get volumes, and then there's a volume types tab. What we're going to do here is we're going to go in. You can see I've got one volume type already created, and that's a default volume type to just push it to the SolidFire array. Not that there's anything else configured here, but we can kind of do this two ways. We can either create the volume type first and then add the QoS specs to it, or we can create the QoS specs, which is what I'm going to do, and then we can go from there. So we'll make a bronze type here, and I'm just going to create one, so we'll kind of walk you through this. You'd need to do 3 or 4 of these steps. All this can be done through the CLI also. If you're interested in CLIing it, I can show you that, but it's not quite as sexy up on the screen, right? So we can then manage the spec, and we can start adding key value pairs here, right? So we say min, and half of these are typed in. So we put a min IOPS. We'll put, I don't know, 800 into here, not 8,000. And then we start to create these pairs. So we're going to create a min, a max, and I don't know, we'll put 1,600 just to always get one extra 0. And then we can put a burst IOPS in here. So burst IOPS, min is the minimal we will supply to that volume. Max is a maximum number if we're constrained. Burst is if you're below your max for a while, you start to build up credits such that you can burst above your maximum for a finite amount of time, right? And that burst number is that how big that high that burst can get. The length of it is determined by how long you've been under your maximum number. So we'll put, I don't know, 3,000 into here just for giggles. Once you're done with that, you can close out of that. You'll see here that we now have a bronze spec. We can go create a volume type. We're going to make this one also bronze. Again, you could mess with these, and you could say this is, $3 a gig, and it could relate to bronze. You can do that as you want. You create the volume type. Then you can manage the QoS association. So you do that. You'd pick the bronze, of course. Everything's called bronze in here, so it makes it work out pretty well. The other thing you can do is when you view this is the extra specs, right? And this is things like you had a couple in your slide deck that you could pull in that would tell the array something. We're going to call volume backend. Oops. Name here. And we're going to put solid fire in here. So this is a way, if you had multiple arrays that like those QoS specs don't necessarily apply to other arrays, you could, or if they did and maybe they were defined a little differently, you can call out those arrays specifically. And this one has a nice little feature in it, but it actually works. So I have practiced this and I know that was going to happen. So it does actually set the extra spec. So now we've got our volume type there. Again, you would normally go through and set up a silver and a gold. I'm just going to actually log out and then log in as demo and show you what that looks like here. So now when we come in as the demo tenant and we went in and we said we're going to create a volume, we'll give it a name. No source, we'll just empty volume, but that's where you could clone it from glance. And we can say, okay, we want that to be a bronze. So you see the selections come up there as you define those as the admin. We'll just leave that as a gig and it should create it here. So we can then go over to the SolidFire GUI, refresh this here. And we should get a volume here momentarily. Nope. Pardon? Was there an error over there? Yep. So it's possible that I mistyped something. So we'll just go. I'm going to go create this out of the one that was predefined. Now this is going to pick up the default QoS specs. Yeah, I got to do that. This is where you guys are laughing because I'm doing the unconstrained demo. All right, so that one came available. When we refresh over here, I think I know where that one. So you can see that volume is created there. If an account wasn't already created for the demo tenant, it would have been created. There it is. The interesting thing is that this UUID here is actually the UUID in OpenStack, right? So if we go over here and we click on test, you'll see that UUID or that ID is the name of the volume that shows up on the SolidFire array. And if we go into the QoS specs, again, this one picked up the default, which is always 100, 15,000, 15,000. The bronze one, if we go back and fix it, when it comes across, it'll be right. So let's go back and fix it.
I have a question.
Yeah.
Would the username that's in SolidFire have some correlation to the actual tenant's ID in OpenStack?
There's a direct mapping that we can go look up. It's not as easy as you would like it to be, but we can go pull that out of there. So let me go back here. Of course, I'm gonna have to log out of here and go back in as admin. Is the what? The extra specs? The QoS is, no, it's available to the community. So the other driver that I wrote in my previous life actually took advantage of this too. Not to the same extent that SolidFire did. We didn't have as good of QoS, but it was something that you can pick up and however you can implement it in the array. You know, a lot of, so let me just, I've been in the storage industry for a lot of years. The QoS has always been something we've talked about in the industry, but in various older architectures, QoS meant, well, I'll prioritize this request over that request. It didn't really affect the overall, I mean, if 2 requests came in or somebody was busier, we prioritized, but we didn't say, you get 100 IOPS and you get capped at 200, and that's all you get, and maybe you can burst. You can set the burst to the same as the max, and then they only get from 100 to 200, right? That's how SolidFire did that. Because we architected the array from the beginning around that quality of service. So our founders worked for a large cloud provider, And this was a problem that they had been wrestling with, and that's why they designed the array that way. So you can set, you notice I set them as min IOPS, max IOPS, and burst IOPS. Other people use different nomenclatures for those. They just come in as QoS with is the key, and then the rest of it is kind of free form. Or you could set them as extra specs too. So whoever had used this demo environment before me had actually not set them in the QoS spec, and they had just set them in the volume type, and you can just set them in there too and go that way. So it's available to everybody. Whether the driver takes advantage of it or not is a different story. Wow. So if you're using the VIO, the VMware Integrated OpenStack, specifically, yeah, there would be a couple of layers you would have to collect some of this stuff from. In a pure...
I want to get data from solid file array. Is there a data store which is, or stat store which is defined from which I can bring data from? Or?
Yeah, well, we're fully API. Our array or our cluster is fully API driven, so you could grab that stuff, you could have a script, you could have some kind of automation that could have hooks into there, or you can get a lot of this, if you're trying to bill your customers, you would build them from OpenStack, right? So Cinder keeps track of, oh, I allocated a gig to this user or that user, so that billing information can come, or would come from OpenStack.
So I can essentially talk OpenStack like
Yeah.
or something.
Yes. Let me see if I can get this fixed here.
I think we believe you would work.
Okay,
You don't
all
have
right.
to fix the problem.
I can fix it if you want, but I think I fat fingered the solid fire and the volume backend name. I've done that before, and it blows up that way. So that's basically the demo. It goes through and you set up your quality service. That's how you kind of do it. With that, I'll let you back at whatever remnants of pizza and if there's more beer back there or questions.
You mentioned multi-tenants. How do you keep tenants from seeing each other's data? Via the login?
So on the array, yes, so, via the login, right? So that tenant has a login. But OpenStack fully abstracts you anyways, right? So if you're in OpenStack and you're tenant A, you never see what is happening with tenant B. Now, what you don't want to happen is tenant B to start sucking up all the storage resources and A goes down, right? And that's where kind of that quality of
Well,
service.
you don't want A also somehow taking the stuff inside.
Correct. Correct. In OpenStack is all about keeping the tenant separate. Right? That's his whole premise was how do I have multiple users of this cloud and I keep them separate. So
You're depending on OpenStack.
we are depending on OpenStack to do its job. We have facilities to make that, carry that all the way through to the storage, but we really depend on OpenStack to do its what it's supposed to do. That would be a major flaw in OpenStack. Allow that.
So when you were talking about,
I'll table him and we start talking. I'll keep coming back to you.
so when you were talking about performance of other competitor drivers for storage, you guys keep track of that just to compare your own, or?
So from a driver perspective, they're all kind of similar because they all use either a RESTful API or an SSH or some kind of a, Now, some vendors use like proxy servers to have a RESTful API and then calls it to the proprietary or something like that. So, yeah, so there's some difference in the vendor implementations behind the scenes, but actually the driver itself there isn't a lot of, no. Again, the reference implementation using LVM, that's a different story, right? So just keep in mind that reference implementation is there so that out of the box you have something to provide storage. Your mileage may vary with that, but the intention is, or the thought is that you would pick some piece of storage that would go from there. So.
Coming back to the multi-tenant,
So yeah, we as an array vendor, wipe the disk, or it knows that there's nothing in there, and so we'll present zeros. Everything we do is thin provision, so we always present zeros. Similarly with LVM through the reference implementation, I don't know. You'd have to ask the other vendors exactly how they do that, but yes. We don't have that capability today. There's some thoughts of doing that, and there are packages that you could add to pieces here and there to make that happen already. There's some, you could do it externally, yeah. Yeah, right, yeah. You could turn on encryption. So the interesting thing is in OpenStack, the volume is presented to the hypervisor. The hypervisor then presents that through the block layer to KVM if you're using KVM. Now, we'd have to talk to VMware about how they do it. So you could, at the hypervisor layer, with some swizzling in Nova, put an encryptor there too. So that would be, yeah, you'd have to fiddle with, and I don't know that the Nova driver supports that today, but there's some interesting work going on to pull some of the, right now, one of the slow parts in Cinder is that everything, when it gets mounted to Nova, that code's in Nova, and it's kind of a duplicate of some of the code that's in Cinder. And so there's work starting to pull that out of Nova. It hasn't, there's still a little overlap, and there's a ball of code called Brick, and I don't know what the latest status of that is. What? But it's not in Nova, right? Nova's not calling the Brick library yet. It will be in Liberty. Okay, so that's what I was getting at, is the work is starting, and it is in Kilo. It's there to pull that brick together, and then in Liberty, they're gonna take that code out of Nova, and they're gonna call the common library that comes from the Cinder group, and that way Cinder can now maintain that and be a little more faster or a little bit faster in iterating the code in Brick. I don't know if we're gonna get a lot of changes in that code through Liberty, because the pulling it out is a lot of effort. Mike can probably comment more on that. So it's kind of like we did some pre-work in Kilo, we'll get it pulled out in Liberty, and then whatever comes after Liberty is where you'll probably start to see some acceleration of the features in that code, right? So there's a little bit of extracting it and creating the APIs and all that kind of stuff. That would be something that would then go into the Brick library. When it mounts it up, it could turn on the encryption at the hypervisor layer, right? But right now we have to go through the Nova project, which has got a lot of activity going on. It's hard to get stuff through that project. So.
I don't know exactly what Nova has available for encryption. I know currently today inside of the gate testing there are. So every single change that goes through gate testing, like normal guide, and so on. There are gated tests that do verify encryptability. So there is some concept that exists in Nova today for encrypting block storage, but that would be coming completely from the actual instance and writing that data, from the instance through the network to whatever storage array you have.
Right.
Yeah. So I don't know exactly what different ciphers are supported with that.
That's.
There is, yes. So there's a whole separate cipher
Yep.
that is completely dedicated to managed Barbican.
Yep.
And Cinder also supports that as well.
BARBCAN. Yeah. That's the key management piece. And then I suspect the ciphers that would be the ones that are in the kernel, right? In the basic, there's a library that.
Actually, with Cinder, there is a concept of a sort of, it's a third secret model, so that
Yeah.
Yeah, I'm not exactly familiar with how, because I've only tested it without Barbican. I haven't verified because there is once again a reference implementation of that, so you're not using Barbican directly. So yes, that is possible. And also what came out of the, let's see, it was in the Kilo release. You can also begin to back up those encrypted volumes as well. It was also new. Yes. Barbican. I don't know. Yeah. Yeah, if you're using the reference, then that is a secret that you know. You know, like nothing else knows. So you have to, at the time of actually, the initiator would have to have that secret passed along. So it would have to be at the time that you're doing attachment. That is actually happening at the Nova volume attach CLI call. A GUI or the command line interface as well. Yes.
Any other questions? We got the PTL here, so if you got specific Cinder questions, you can ask him or go ahead.
Are there public benchmarks with like
So I wouldn't say that the community is going down that route. I'm sure each individual vendor has run some of those tests. No, I'd say that's a vendor, right? The community is really trying to foster cooperation and usability of Cinder amongst a bunch of different array vendors, right? So as a community, we're not here to foster bashing. You'll notice I tried to not take any other vendors. Yeah, that's one of those things where how do you select an array today, right? So you need to go look through some of that. So, other questions? Yeah. Yeah.
So the question is, does Cinder support stuff? And yes, actually,
Yep.
that was the previous driver that I was working on. Yeah, so stuff was actually one of the first drivers along with LVM that was integrated in 2010, back in Nova Volume. And so it's integrated in there as well as, you can integrate it into Glance and a variety of other things besides block storage. It also offers object storage. So, are you able to talk about how SolidFire does its image caching? It's a
Sure. So when we clone the images, Don explained this the other day, so I might get it.
well, if you don't want to talk about it right now, so.
Basically, when you're looking to take an image out of Glance and clone it into a volume, it has to be pulled out of Glance every time. So we've implemented the ability to pull that into the SolidFire array, and if you do it again, we can just make a quick clone. So we keep a Glance cache, basically, in the SolidFire array, and we can quickly clone them. We do have to go back every time and check and make sure it hasn't changed, right? So that gives us a couple of steps.
Yeah. So typically, what would happen whenever you wanted to say create a volume and you want to set an image to that volume and you want to boot off of that volume to an instance, typically what would happen is that image would it would have to come from whatever backend store that Glance is using that has that image, and then it would have to download it over the network onto. For some storage arrays, actually bringing it over to the hypervisor, which then redirects it to the volume, which is on some other storage array, so you're doing a bunch of hops. So check out your drivers. A lot of them are really good about being really smart about how they're doing caching on taking images, so you're not doing all those hops. If you're using things like LVM, it's going to be incredibly slow on dealing with those sort of things. If you take also like the Ceph solution, for example, Ceph provides an object store, and there's a backend store to Glance. So anytime, typically like your images of your instances would be stored into an object store, Swift or Ceph's Rados gateway. And so you would have the instances stored on there, and then anytime you wanted to do like a copy on write, that would not ever leave the Ceph cluster because the image is stored on the Ceph cluster. So if you wanted to create a copy on write and create a volume with a particular like trusty Ubuntu image, all it does is point to where that image is at and puts all the writes on top of it and that volume. So pretty quick. Yeah, and then so of course other drivers are leveraging other really smart things that you could do with caching. So, and SolidFire has that in the Kilo release now. So.
So the SolidFire array is fully used, right, throughout the cluster. Efficiency is one of our 5 keys, right? So it compresses it and you use it across the whole. Replication is available in the array. There's still some work to be done in the OpenStack part of Cinder to make that all work. We have some non-community drivers that under the covers. We're waiting to kind of get that all worked out and then we'll have it in the driver. Still some work. All right, I think I'm going to call it. I'll take one more. There's some limits you can set in glance for how big they are, but no, you just clone them down and make them into volumes. It's going to have to copy it over the network. It's got to pull it out of glance and copy it over the network. So you may want to build an image and then clone that image, right? The cloning of volumes comes relatively cheaply on most arrays because it's a snapshot and a clone. But if you're actually doing an instance, create a volume from an instance, it's got to copy it from wherever it is in glance, and that's what we're talking about with this image cache. So I can copy that down once and then you clone. Or if you're in something like Ceph, they have the images. You might have glance configured to use Ceph, and then you can do that. So there are some timeout values you also may have to adjust based on how long it's going to take to pull that thing out. It's slow, right? And there are some timeouts. I have run into a bunch of those lately, and so you have to either up the timeouts or, it kind of will fail, but it's still going on in the background. Something else will time out, and you just let it happen, and then go back and clone it from there. So, yeah, there's some tweaking to that. We have some customers that are just not using glance. They're just making volumes, and they have some conventions, and then they clone the volumes because that's, again, on the array, that's a pretty lightweight operation on most modern arrays. It is on ours, right? But again, on most modern arrays, that's so. With that, I think, thank you all. Any other questions? We'll be around up here, and eat some pizza, there's some mints and stuff in the back if you want trinkets, so. Thanks.